there, this is part 2 of the wave function videos. We're still looking at the cos expansion, but this time we are looking at the expansion where it's x plus alpha. So that is the one where it becomes cos minus sin. So you need to be a wee bit careful with your signs in this one. So let's get straight into an example. So we are expanding into this form today. So I'm just going to start by writing it out. So we have cos x, so step 1 is do your expansion, plus root 3 sin x equals k cos x cos alpha, and then k sin x sin alpha. But because it's a plus in the middle, with expansion that becomes a minus. So we want to still get k cos alpha and k sin alpha. Okay, let's do our underlining. So cos is still with cos, and cos doesn't have anything in front of it, so cos alpha is just number 1. This is a bit we need to be careful with, right? So our sin is still with sin, but you'll notice there is a minus in front here, so we have got, technically, we've got minus k sin alpha, and that equals positive root 3. So I do that and I write it as negative k sin alpha equals root 3, and then I change the signs. So I make that one positive and I make that one negative. So we've got negative for the sin, positive with the cos. And then k will be the Pythagoras bit where we do 1 squared plus negative root 3 all squared. And that just gives us basically 1 plus 3, which is 4. And the square root of 4 we all know is 2. So we've got k is 2. For tan alpha, tan is still sin over cos. So we've got negative root 3 all over 1. If I go to the ticky bit, so cos was 1, so cos was positive. Sin was negative, so you tick tan and cos. And then tan was a negative fraction, so tick sin and cos. So we can tell we're going to be using the 4th quadrant. So our acute angle, when you do shift tan of root 3, I think I've done an example with this number already. When you do shift tan of root 3, we get 60. I should know that from my exact values. So we get the angle of 60, but obviously alpha is 360. Take away 60 because we're applying it in the cos box. So alpha is then 300. And then the way I finish all my questions is I just always write the question out again. So we have cos x plus root 3 sin x equals, so k was the number 2, and then we had cos bracket x minus alpha, which was 300. So the last step is always your substitution. And then that there is your final answer. Okay, let's have a look at another one. Okay, so I'm going to go straight into the expansion again. So we've got 3 cos x minus 4 sin x. So you've got k cos x cos alpha. It's a plus, so we have a minus now. And then we have sin x sin alpha. So we've got k cos alpha equals. And then again, it's going to be a minus sin alpha on this one. So minus k sin alpha equals. Okay, underline a bit. So cos x is with cos, and cos x is with 3. So k cos alpha equals 3. If I do the sin bit, so sin x is with negative k sin alpha, and sin x is with negative 4. So because I've got negative k sin alpha equals negative 4, the two negatives will turn that into a positive. Okay? So the Pythagoras bit will give you k equals the square root of 3 squared plus 4 squared, which we all know is 25 because it's your classic 3, 4, 5 triangle, which gives you k is 5. Tan of alpha will be sin over cos, so that's 4 over 3. Everything is positive in this one, so it's going to be the all box, right? You're going to have that, basically. If everything is positive, your cos, your sin, your tan, we're using the angle that comes out. So we're just doing shift tan of 4/3, which is, to the nearest degree, it gives us 53 degrees. So alpha is 53. We don't need to do anything with that one. So just to finish the question, we've got 3 cos x minus 4 sin x equals, then that leaves us with 5 cos bracket x minus 53. And that was our final answer we were after there.